This video is going to be for pie charts. So this should be something that you've already seen before, but maybe not. This could be just to refresh your memory. And then your learning target is I can create and analyze pie charts. Okay, so let's go over this stuff. So a pie chart is a graphical display of qualitative data. Which means it's not like numbers. There's going to be percentages, but you're looking at something other than numbers. The data is presented as percents, so that's where your numbers are going to be. All right. The circle, because it's always a circle, it's a pie, is divided into sections, representing the different categories that you're talking about. The size of the pie is going to be proportional. So if I say something is 50%, then it's going to be half of the circle. If I say something is 25%, it's going to be a fourth of a circle. So it's proportional to the frequency of the category. So how often it occurs. Alright, so let's look at this very basic survey. In a survey of 60 people, 20 people like chocolate, 30 people like mint chocolate, and 10 like raspberry. Gross, but that's what it is. So what I'm going to do over here in my pie chart is I'm going to fill that out. So 30 out of 60 people like mint chocolate, so that's going to be 50%. So I'm going to say 50% is going to be mint chocolate. Those people are gross, but whatever. Free country. 20 out of 60 like, regular chocolate. Those are my kind of people. 20 out of 60 is a third, so I would say 33%. And then I don't know who these people are, but 10 of them like raspberry. Whatever floats your boat. So 10 out of 60 is a sixth. If you put that in your calculator, you can round that to 17%. Okay, so here's how I got this, if that didn't make sense. Alright, so chocolate frequency. 20 out of 60. If you put that in your calculator, you get 0.33 repeating. If I change that to a if I change that to a percentage, it's 33%. The next one was mint chocolate. 30 out of 60, which is 0.5. That's how I got 50%. And then raspberry was 10 out of 60. And when I put that in my calculator, I get 0.166 with the 6 repeating on forever. So that's 17%. So that's how I got those percentages. Alright. So we went ahead and did step 1 and 2 just to save time. Okay, so sometimes they'll talk about relative frequency or relative central angle, where you don't really have to worry about the relative central angle so much. I just want to show you what it means. So in this example, a survey asked 130 AP students about their movie preferences, and the results are shown below. So we're going to make and interpret a pie chart. All right, so over here is a little formula. Relative frequency is found if you do the category frequency divided by the sample size. So if I look at comedy is 32, that's your category frequency, divided by, there were 130. If I put that in my calculator, I get 0.246. Okay. If I want to find the relative central angle, I'm going to do 360 times the relative frequency I just found. Alright, so when I multiply that together, I get 88.615. So when I make my pie chart, the angle I create for comedy is actually going to be 88.615. So if you were to get a protractor out and actually measure it, but who has time for that, you should be finding that angle. So that's how I find this stuff. Alright, and now we're just going to fill out the chart. Alright, so horror, 46 out of 130. Put that in my calculator, and I get 0.354. If I times that by 360, then I get my relative central angle of 127.385. Drama is 15 out of 130. So when I put that in my calculator, I get 0.115. If I multiply that by 360, I get 41.538. Okay, action is 27 out of the sample size of 130. Put that in my calculator, I get 0.208. I multiply that by 360, and I get 74.769 for my relative central angle. And then the last is documentary. So that's 10 out of 130. And I put that in my calculator, I get 0.077. Multiply that by 360. That's how I get 27.692. So now what we're going to do is we're going to draw a pie chart using this. We really aren't going to focus on this relative central angle so much, just because I think it's kind of dumb. We're just going to sketch a pretty rough draft. We're going to make it kind of proportional. Alright, so I'm going to pause the video and I'm going to draw one. If you want to try it, you can. I'm going to color code it using the colors on the screen that you see. So try it in 1, 2, 3. So something close to that. So you can color code it. You should always label it. If you didn't have colors, you can at least write that this one is action. You write that this one is documentary, stuff like that. So labeling is very important. If you're not color coding it, at least you're writing down the categories, just so you know how to read it. Alright, and then let's look at this one. So, I want you to try this one. So, how do students get to school? The results of a survey is shown below. Create a pie chart and interpret. So, the first thing I want you to do is fill out the relative frequency and the relative central angle using the same formulas we used in the last one. So, I want you to pause the video and try it in 1, 2, 3. Alright, so here's what you have. So, bus 0.167, bicycle 0.250, walking 0.333, car 0.111, scooter 0.139, using those same formulas that we just looked at. Okay, so now what I want you to do is I want you to actually draw a pie chart. Label it. If you're not going to color code it, you can label it and color code it, however you want to do it. Try it. Does not have to be perfect, does not have to be pretty, does have to be labeled and a little bit accurate. You can do it. So try that in 1, 2, 3. Okay, so here's mine. I color coded it, I labeled it, I put the percentages, I did all of it. You can have it in a different order, that's perfectly fine. It should just look something like this. Alright, and now we're going to analyze it. So we have two questions. What is the relationship between people who walked and the people who took a car to school? So 33% of people walk, and then 11% take a car. So I would say something like 3 times as many people walk to school. Or you could say, like for every 1 person who was in a car, 3 people walked. So it's really, it's kind of, answers are going to vary. So as long as it makes sense mathematically and it's a complete sentence, I want to count it. Alright, and then the last one says, what percent of students take a vehicle to school? So a vehicle would be a bus, a bicycle, a car, or a scooter. So if you add all 4 of them up, so that's 17%, and then 25%, and then 11%, and 14%, you should get 67%. So 67% of people take a vehicle to school. So that's how we make a pie chart, and then that's also how we look at the pie chart and analyze the data. Alright, so let's try one more. This one, on a study, a researcher notes the frequency of different types of animals. Her data is shown below. Create a pie chart and interpret. First thing I want you to do, pause the video, and I want you to fill out the table. So do that in 1, 2, 3. Okay, so here's what your chart should look like. Remember, you're using those 2 formulas we talked about earlier. You're just doing the category frequency divided by the sample size, and then to get the relative central angle, you're multiplying the relative frequency by 360. So that's how I got all this. So now I want you to draw your pie chart and label it, color code it, whatever you want to do. Just make sure it's accurate. Try that in 1, 2, 3. Okay, so something like this doesn't have to be beautiful, doesn't have to be perfect. Mine's definitely not, but it's accurate and everything's labeled. So now we're going to analyze it. So number 1, which animal appeared most frequently? So that is definitely birds, because it has 40%. Nothing's bigger than birds. Alright, and then what percent of animals live in the water? So you just look at the water animals, and it's 22.5. So pie charts are super easy to make. They're super easy to analyze. I think you're going to be fine with it. If you have any questions, just send me a message, and I'll try to answer. Bye!